Hi, so this is question 88 on stoichiometry. In the experiment, 330 grams of iron is obtained. Calculate the percentage yield if we used all 500 grams of iron oxide. Okay, so this is iron oxide here, or this is what they mean by iron oxide, this one. So now this is your class one. This iron oxide, is it iron 2 oxide or iron 3 oxide? Let me know in the comments. Right, so let's continue with this question. In the experiment, 330 grams of Fe, that's iron, is obtained. That's the amount obtained. Maybe they measured it and then they, weighed it and then saw that it was 330 grams. So that would mean that the actual yield is equal to 330 grams, okay? That's what it means. Actual yield. All right, so we're to calculate the percentage yield, but we know that percentage yield is actual yield divided by theoretical yield multiplied by 100%. That's the formula for percent yield. Actual over theoretical times 100. So we already have actual. So that means you know the next thing we're going to do, try to find theoretical. So the theoretical yield of iron, talking about the yield of iron now, is the amount of iron that should be produced from calculation. All right. So if we used all 500 grams of iron oxide, it means that we have Fe2O3, 500 grams, and we are looking at, we said it was used up, right? We used all. So we're going to assume that that's the limiting reagent and we'll work with that. So we're going to have to compare the Fe2O3 with our iron itself, okay? And that is 1:2 from the balanced equation of reaction. Now, the 500 grams that you're seeing there, we have to convert that to moles. So you divide by the molar mass of Fe2O3. So what's the molar mass of Fe2O3? That's 2 multiplied by the Fe, which is 56. And then we have 3 multiplied by 16. What does that give us? Is that 160 I'm seeing there? All right, so I have to divide 500 by 160 then. And that should give us about 3.125. So that's the number of moles of the iron oxide. Now, since 1 mole of iron oxide produces 2 moles of iron, it means that with our 3.125 mole of iron oxide, it's expected to produce 3.125 multiplied by 2. Yes. So the number of moles of iron that should be produced theoretically would be 3.125 multiplied by 2. Okay? And when you do that, you'd have 6.25. 6.25. That is the moles of iron. So can we use this moles of iron to then figure out the mass of iron? Yes. The mass of iron is the number of moles of iron multiplied by the molar mass of iron. So that would be 6.25 multiplied by the molar mass of iron, which is 56. When you do that, you obtain 350 grams. So it's at the end of the page, but this is not the end of the question. 350 grams is the amount of iron that should be generated by calculation, right? Meaning that 350 grams is our theoretical yield. So we are almost done. We just have to say that the percent yield now will be equal to the actual yield. What's our actual yield again? 330 divided by the theoretical yield, right? Which is 350. So that's 330 divided by 350, and then you multiply it by 100%. So if you do that, you would have 94.285%, and that is our answer. Let me remind you guys that if you're looking for a tutor for chemistry and math and then your other schoolwork, you can head up to our website, copychemistry.com, and then click the book a session there. So your tutor will connect with you, and your life will be better academically. All right, so that's by the way. And if you have any further questions regarding this question 88, let me know. If you would solve it in a different way, also let me know. And then if it was helpful to you, give us a like here, and I'll see you on 89. Okay, bye.